Hello everyone, today we'll be solving this question, this integration problem which has got some trigonometric relations in it. So you'll need some trigonometric ideas, but then it's not very difficult. There can come a time where it's a bit tricky, but then other than that it's pretty simple. So as I've told in my previous videos as well, first of all you try to change it in the form of square, or try to open it in some kind of formula. So first of all we're going to open sine x in one trigonometric formula, that is 2 sine x over 2. It is half angle formula. This is divided by cos x over 2. This cos looks like simple scribbling. Yes, now it's fine. Plus cos x can be written as cos square x over 2 minus sine square x over 2. It's the same thing. Let's extend this divided by sine. So yeah, now what we can do is divide and multiply this denominator with cos square x over 2. So what we get after that is sec square x over 2. 1 over cos square x over 2 can be written as sec square x over 2 dx, and below that we'll have 2 times tan x over 2. So 1 cos x, this one gets cancelled by cos square x over 2 is 1 power, and then the rest can be written as tan sine x over 2 over cos x over 2, plus of course cos square x over 2 over cos square x over 2 is 1 minus tan square x over 2. Yes, after this let us suppose tan x over 2 as any variable, let's say p. Now let's differentiate p with respect to x. It is not difficult at all, but then I'll just explain it to you. So tan x over 2 gets differentiated with respect to x over 2 in the beginning, which gives us this. And then x over 2 again gets differentiated with respect to x, which gives us 1 over 2. So it's not difficult, it's simple differentiation. So after this, let's move on to next page, and is equal to so wait, what we get from this is 2 dp is equal to sec square x over 2 times dx. And here we can see that we have sec square x over 2 times dx. So now let's replace them in the above form. So what we get is equal to integration sign, of course, 2 dp, this is d over 2p plus 1 minus p square. So is equal to, the next step would be, let's take the 2 outside, dp over minus p square plus 2p plus 1, isn't it? So now let's try and reduce this expanded form. Before that, let's take minus common so that the one containing power 2 is positive. Is equal to minus 2 dp over, what we have is p square minus 2p minus 1, isn't it? Yes, is equal to, now this can be written as, wait a minute, it can be written as p minus 1 whole square minus 2. How this can be written is, just check here. So what we can do is a square minus 2ab, that's remembering the formula, which is very important, plus 1 square minus 1 square, they cancel each other out, and minus 1 is something we have from the beginning. So these two can be written as p minus 1 whole square, then if you add this you get minus 2. So this is how you get it. So but now we don't need it, so let's just clear them out so that we have space to continue solving our problem. Yep. So yes, so now what we do is, or if you don't like this minus sign, what you can do is you can take minus common again. So is equal to 2 dp over 2 minus p minus 1 whole square. You can do this. So after this, this looks like a modulus sign. Let's change it, and this again finally can be written as this. Let's change the color. Is equal to, so I've been talking about a formula where the formula of this a square minus x square. So there's a simple formula to this. It helps you solve questions like this. So it is 1 over 2a ln, I think, and it is, I think, a minus, I think it is a minus. So it is a minus x and a plus x, and of course plus c. So that's what we have. The formula, it's nothing that you have to remember. It's like a short form. If you write this as a minus x, a plus x, and then again change it in rational fraction. If you change it to the other form, then you will get this formula. It's nothing very difficult, but then I suggest you to remember it if you're solving a lot of questions. That makes your work easier. So is equal to, let's just, so 1 over 2a, there is 2 root 2 over here, root 2 is a, log p is, oh wait, what we can do is a minus p plus 1 over, oh sorry, a plus x, so it's just opposite. Got confused. Yep, now it is minus 2 minus p plus 1. Yes, this 2 cancels this 2, and finally what you have, your answer is 1 over root 2 log root 2 plus tan x over 2, replacing with original value, root 2 minus tan x over 2 plus 1. So 1 is positive over here, 1 is negative over here, and that's what we have done here. Rest, it's simple. So this is the final answer to this question. If you want to keep this minus as it is, then you can change it in the form of x square minus a square as well. That's also totally fine. But then I decided not to go on with the minus and make it a positive one. So this is it. This question gets solved like this. It's not very difficult. All you have to do is understand some of the trigonometric relations, and that's it. So I hope you learned how to do this, and hope to see you in my next videos. Thank you.